So from the previous video we had worked out value of growth gap. We had downloaded data for Fed funds and inflation, and so we'll call this raw data. We'll give this spreadsheet a name, raw data for Taylor rule. And we'll rearrange. Okay, so let's just take this and copy, and we'll paste into a new spreadsheet. So home, paste, and let's take this series. So I want to copy and paste, and I want to remove the date, so delete, and we'll take the growth cap, copy, paste, and so we'll take this out, delete. The dates still align, all the same dates, so that's fine. So we can take both of these columns out, delete, and we can take both columns here, delete. So what we're left with is Fed funds rate, inflation, and growth gap, all expressed in terms of percentages. And we could set out the following. In line with Orphanides, we could set out the relationship in this format. So let's just write that. So Fed funds equals to, let's say, a constant plus B1 times inflation plus B2 times growth gap. Okay, so this is the basic, if you like, Taylor rule type relationship. We could freeze. So one thing we might consider doing here is just to freeze the panes. So freeze panes, and that means we can come down at any point here to a particular data range. And of interest, of course, is the Greenspan period, because the Taylor rule was introduced in the first paper that Taylor wrote with regard to setting out a policy rule, or his seminal paper was 1993, and that was a retrospective back to the early Greenspan period. So in particular we're interested in the Greenspan period, 1987, probably the last quarter of 1987 up until 2006. So we would like to run a regression. Let's call this the Greenspan period. And we would like to run a regression and linest, and we would like to regress the Fed funds rate. So let's go from the last quarter of 1987 and bring this up to the first quarter of 2006. That's when Ben Bernanke took up his tenure of the Federal Reserve. So, and that's our, if you like, dependent variable. Our independent variable, or variables, is the growth gap and inflation. So I'll just pull that up for the same time period. And then, do we have a constant? Yes, it's true, because in the relationship we specify above, we have a constant, and then true as well for statistics. and if you return you get a value. And then to get the array output, just select a set of cells, probably 4 by 4, 4 by 5, and it's an array output, so in Excel that implies Shift Control Enter. And what we have in our estimation here, if we take this period, is okay, let's just bring this down. Insert, shift cells down. Now what we have, if this is the relationship, then this variable here represents the constant. So it's kind of in reverse order to what we might have expected. We regressed in the what we regressed was fed funds, and we regressed the independent variables inflation and output gap on fed funds, and we wanted a constant, which is true. We wanted statistics, which is our standard errors and R-squareds and so on. Okay, but the order that the values, the coefficients, the order of the coefficients is reversed in a sense. So the first coefficient, or the last coefficient, is A, that's the constant. The second last here is B1, the index on the coefficient on inflation, and B2. Okay, and first thing that strikes us is this is extremely close. I mean, bar what we have here, this constant, this is quite close to what Taylor rule would have specified. So if we go back to what Orphanides, his summary of the Taylor rule, he said the Taylor rule should be R, the fed funds rate should be equal to 1 plus 1.5 plus 0.5 in the output gap, 1.5 in the inflation gap, 0.5 on the output gap. And if we go back and take a look, the values are quite close. So this is close to 0.5, the coefficient on the output gap, or in this case growth gap. B1, in coefficient on inflation, is close to 1.5, and on the constant it drifts a little bit away from 1, 0.36. Now, something of note, this is the coefficients. These variables represent the coefficients. The variables below represent standard error. And this variable here, if I'm correct, is the R-squared. If we want to look at the statistical significance of the variables, or the t-stats, what we might do is just take the coefficients and divide by the standard error. And as a rough rule of thumb, if we're more than 2 standard deviations away from, if our t-stats are exceed 2, we generally have values that are statistically significant, and here we're less, so the coefficient here is not statistically different from 0. So that's in other words, that in our interpretation here, the usual type of interpretation offered on confidence, this could be, there is more than a 5% chance that this value is equal to 0. Some things I've overlooked, obviously things we've ignored here are serial correlation, which there's bound to be because the Fed funds is adjusted only incrementally, particularly during the Greenspan period, so you tend to get high levels of serial correlation. Also, we would imagine that there has to be a relationship between the output gap and inflation. If we think of the Phillips curve and then Okun's rule, there is a direct link between output and growth gap and unemployment and inflation, and these are bound, these are linked together, these macroeconomic variables are bound to be linked together. So in all likelihood we suffer from multicollinearity. Nevertheless, our estimates may not be too badly biased, and we are getting values that are in line with the original Taylor rule. So this warrants some kind of little bit of attention here in terms of our coefficient estimates. Now, also, what may be of interest is how did this change during the period? So we might just write this down here as Taylor rule and Greenspan. And it basically, our relationship here, the Greenspan reaction function that we've worked out doesn't differ very substantially from the Taylor rule. So if we were to compare directly the Taylor rule, this value should have been for B2 0.5, this value should have been 1.5, and this value should have been 1. So we could take this and copy just to make the comparison and paste, and we could have said Taylor rule just to offer the direct comparison. Okay, now what I plan to do in the next video is re-estimate the reaction function during the Taylor rule on using a recursive technique similar to what we implemented when estimating the growth gap.